All right, Spartan fans, so you would need to pick up a note sheet from the sub, and today we are going to talk about the ellipse. Okay, so an ellipse is the collection of all points in a plane such that the sum of whose distances from two fixed points, which are called the foci, not foci, foci, it is a plural of focus. So you have a focal point. So imagine you've got a thumbtack. So here's a focal point, here's a focal point. And you have a piece of string that is taut between these two foci. If you were to pull this piece of string around, leaving these focal points intact, not moving, you keep them constant, you would create what is called an ellipse. And an ellipse is either horizontal or an ellipse is vertical. Okay, so we're going to talk about an ellipse being centered at what we call HK. And HK should now be familiar to you. Okay, C, first of all, is going to be the focal distance, just like it was for a parabola. And notice that you have, here's your center, HK. So your foci could be horizontal in line with the center, or the foci could be vertical in line with the center. That is how you are going to create a horizontal ellipse versus a vertical ellipse. Okay. And so you'll notice that it also says here's H, and then you're going to take H plus the focal distance to get here, H minus C, C is the focal distance. There's two ways that we're going to write these equations. All right, the first way, you're going to have x minus h squared and y minus k squared. But the problem here is that it has to be equal to 1 and not r squared, because if it was equal to r squared, it would be a circle. So it must equal 1. And we're going to divide that by a squared and b squared, and I'll tell you what all the letters mean in just a minute. That's one way to write it, or, so you could write it as the numerator squared over the denominator squared, or you could write it as the whole thing, the whole fraction, quantity squared. These are exactly the same equation. Okay, whether it is numerator squared over denominator squared or the fraction squared. All right. A is the distance from the center to the vertices. So we're going to have two vertexes, two vertices. And the vertices are going to be here and here. The other way, it could be a vertical ellipse, and it would still be x minus h squared, and it would still be y minus k squared, but we're going to switch a and b. And again, you could write that as x minus h over b squared plus y minus k over a squared, and that would equal to 1. And now b is going to be the distance from the center to what we call the co-vertices. And how are you going to find this focal distance? Okay, so I have it highlighted here. But the focal distance is equal to a squared minus b squared. So it's kind of like the Pythagorean theorem, but it's subtraction instead of addition. And we'll throw it all together in an example, and it will make a lot more sense in a minute here. All right, so let's analyze the equation of the ellipse. The first thing is that it must equal 1. When you are talking about an ellipse, the equation must equal to 1. Let's start there. So I gave you 9x squared plus 4y squared equals 36. Okay, well, that's a problem. How about x, not y? Because right now it equals 36, and I need it to equal 1. So I'm going to divide both sides by 36. Okay, and so I'm going to write that as x squared over 4 plus y squared over 9, and that's going to equal to 1. All right, so I don't really necessarily worry about what's A, what's B, etc. which denominator is larger? So last I checked, 9 is greater than 4. I think we can agree with that. Notice that 9 is underneath y, and y is vertical. So this is going to be a vertical ellipse. And that is simply because the 9 is underneath the y. So this ellipse is going to open. It's going to be taller than it is wide. The center of this ellipse is at the origin. Nothing's being added or subtracted. So I'm going to put my center at the origin. Okay, well, now I got to figure out this whole thing with the vertices. So 9 is the same thing as 3 squared. So in the y direction, I'm going to go up 3 and put a point. And I'm going to go down 3 and put a point. And those are going to be my vertices. And they are going to be at 0, 3, and 0, -3. And my major axis is going to be y. And that is because it is a vertical ellipse. The major axis is always the longer one. And in this case, the longer axis is y. So the co-vertices are the smaller. So we already decided that 4 was smaller than 9. So 4 is 2 squared. So in the x direction, I'm going to add 2 and I'm going to subtract 2. And those are going to be my co-vertices. And that's going to be at 0, 2, 0, and 0, -2, 0. 2, 0, -2, 0. Okay, so this is going to be my ellipse. But now we have to deal with this thing called the foci. They are always inside the ellipse, just like the focus is inside the parabola, they are inside the ellipse. All right, always, always, always the major minus the minor, the larger minus the smaller. So my focal distance is going to be equal to 9 minus 4. Try it the other way around. If you do 4 minus 9, you get a negative number, and that can't happen. You can't square root a negative number. That's another way that you're going to know whether or not you did it right. So c squared is going to be 5. C is going to be plus or minus root 5. That is my focal distance. It is always, always, always on the major axis. Okay, well in this case, this is taller than it is wide, so y is my major axis. So from the center, I'm going to go up root 5, and I'm going to go down root 5. So the square root of 5 is a little bit more than 2. So I'm going to go up a little bit more than 2 and put a point, and I'm going to go down a little bit more than 2 and put a point. You must always graph the foci. So the foci are at 0 root 5 and 0 negative root 5. Okay, so now we're going to analyze the equation of an ellipse that's not at the center. Notice that it already equals 1 for us, okay, so that's nice. 25 is the same thing as 5 squared. 9 is the same thing as 3 squared. 5 squared, 25 is greater than 3 squared, 9. 25 is associated with x. It is the x denominator. So this this ellipse is going to be horizontal. And the major axis is going to be y. I lied. The major axis is going to be x. I lied. The center of this ellipse is at 3, 1. I got that because 3, my opposite of -3 is +3, opposite of -1 is +1. And now in the x direction, I'm going to move right 5, which I don't quite have enough room, and left 5. So I am going to cheat a little bit and put on here 7 and 8. So I'm going to have a vertex at 8, 1. Vertices, plural vertex, and I'm going to have another vertex at -2, 1. I moved 5 right, 5 left. Okay. minor. Okay, so y is associated with 9, which is 3 squared. So in the y direction, I'm going to go up 3 and down 3. So my covertices, it is important that you would distinguish between covertices and vertices. That's at 3, 4, and 3, -2. And now the foci are super important. The foci are what creates the ellipse. Okay, so the foci are always the larger minus the smaller. Last I checked, 25 was more than 9. So that's 16. And so that's plus or minus 4. So in the x direction, I'm moving right 4 and left 4. Notice in the previous problem, I went up the focal distance and down the focal distance, and that is because the major axis was y. Now that has switched. So I'm going to move 4 to the right and 4 to the left. You have to graph them. The foci are at 7, 1, and -1, 1. Okay. Last thing. All right, so now we're going to work backwards, and I'm going to give you the information, and you're going to write the equation. Okay, so for this one, I'm telling you the center is at -2, 4. It makes no difference which way this ellipse opens. -2, 4, there's your h and your k. X plus 2 squared plus y minus 4 squared equals 1. That's where I'm going to start. And I'm going to have some denominator squared and another denominator squared. Okay, so -2, 4 is here. Great. And then the focus is at 1, 4. So 1, 4 is here. That's a focus. I'm going to label it F for focus. And we have a vertex at -7, 4, which is here. That's going to be a vertex. All right. This parabola opens horizontally. From the center, you moved right to get a focus. From the center, you moved left to get a vertex. If this had covertice, it would be a different scenario. All right, so the distance from the vertex to the center is 5. That is the x direction. So it goes with x. So now I have x plus 2 squared over 25 plus y minus 4 squared over something equals 1. They gave me the focal distance. So from here to here, that is 1, 2, 3. So C, my focal distance, is 3. Because this is a horizontal ellipse, 25 must be greater than whatever the y denominator is. Horizontal x, that's the major. The major has to be more than the minor. Now I'm going to work backwards to find out what the y denominator is. So c squared equals the larger minus the smaller ab. So c squared, that's 3 squared, is going to equal 5 squared minus b squared. Subtract. B is, so b squared, there you go, 16. Your equation is x plus 2 squared over 25 plus y minus 4 squared over 16 equals 1, or x plus 2 over 5 quantity squared plus y minus 4 over 4 quantity squared equals 1. Which way is better? Makes no difference to me. Okay, so notice that regardless of which way the ellipse opens, the center is at HK, period. Now, the major axis parallel to the x-axis. So that is what we did in the second example. Major axis parallel to x. Major axis was horizontal, it's parallel to x. That is a horizontal parabola. So I keep saying parabola, I mean ellipse. You're going to add and subtract the focal distance from h. When it's a vertical parabola, ellipse, you add and subtract from k. So this one's going to be vertical. The vertices, add and subtract from h for horizontal. And if it's vertical, you add and subtract from k. And then the equation we've already done. X minus h over a squared plus y minus k over b squared is 1. And then if it is vertical, we're going to switch a and b. But again, I literally, I've been doing it forever. I don't memorize which one's b and which one's a. Major is always longer. And the vertices always go on the major axis. So the vertices are on the major, and the foci are on the major. And that is a crash course in ellipses.